Okay, in this video, like to take a look at the Wizard rocket and how I re-engineered this. This rocket is a very nice rocket. Matter of fact, I don't think there's a rocket that I'm not going to say that about. I really enjoy rocketry, and every rocket has got a slight personality to it, so I enjoy building all rockets. This particular rocket is a very simple rocket, usually a more introductory rocket for people to build as a first rocket. It flies extremely well, and a simple A83 will send this thing up very, very high. And it again will benefit from having a streamer in it to help the tracking. But this rocket had some other issues, and I wanted to fix those issues in order to have, as this channel is on engineering, a better engineered solution so that I can have a more reliable flight. So if we look at this rocket more specifically, you'll notice that there's an engine clip in this particular rocket. And this rocket does not come with an engine clip. It comes with a friction fit. So when you put the engine in, you have to wrap some tape around it in order to tighten that up so that the engine doesn't fly out on the ejection charge. That is not a very good solution from the point of view is like, how much tape do you use? You use too much tape, you might not get the engine out very easily. If you don't have enough, the engine is going to fly out. So how do you know how much tape to put in there? Granted, many people have commented, well, you know, after a while you get good at that. Well, you might get good at that only after you lose a couple of rockets. So I myself was concerned about this rocket when on one flight the engine ejected and the rocket came down. The nose cone popped off, and that's probably the only thing that kept it from serious damage, that it tumbled a little bit. So what I did is I said, okay, this rocket needs an engine clip. So to put an engine clip on this rocket, what I did was to take an engine clip out of a engine pack. It was like, there's like a pack you can buy in engine mounts. It costs like maybe, I don't know, 50 cents or something like that. And I put this on, and I measured back where the actual engine block was. And I then wrapped around this. This is hard to see because I did paint over this again, but you can see that there is 2 lines of Kevlar wrapped around this. It wraps around, and it wraps around over here. And it's the same Kevlar that I use for making the small streamers. It's like this. This particular Kevlar is the 100-pound Kevlar. It's very thin, and I believe it's 0.8 of a millimeter. So I put this engine clip on, and it needs something to hold it in the middle so you can flex it backwards like this without it popping off. And that's what I used. I just used 2 wraps of that. And the final key to solving this problem is to use the E6000 glue. I've talked about this many, many times. It's a polymer glue, which is similar to an epoxy, but instead of a hardener, it has a solvent which evaporates. It does take approximately 1 to 2 days to reach its maximum strength. Once this has hardened, it is incredibly hard. I'm going to say incredibly strong. It is a slight bit rubbery, but that's good because in cases where it's got a lot of stress, it's going to flex just a little bit rather than cracking. So this is a very nice glue for model rocketry for this particular application. Now, this application is nice because it's going to have the flexing of this plus the flexing of the rocket here. Okay, so this is one problem that I fixed, and this works out very nice. You just put the rocket engine in the back. Now there's a positive mechanical mechanism holding this in place. But this should really be kind of a little bit of a concern for the particular method of using streamers. Streamers take a bit more pressure to push out. The pressure is available, but it takes a little bit longer to develop. So when the engine is firing its ejection charge, it's burning. It doesn't happen instantly. It happens over a few milliseconds. And if the pressure gets too high, the engine flies out. But we need that pressure to push out the streamer. So we need something to hold that engine in place while the ejection charge is building up its pressure. It's only a split second of amount of time, but if you do not have an engine clip, you're only doing friction fit, you may not have enough friction, and it's going to fly out, your rocket's going to come down, and that could be the end of your rocket. So that was one problem that I fixed on this. Now the second problem is like, okay, this is a minimum diameter rocket, namely the body tube is really the same size as the engine mount, and it is the engine mount. So how do you attach a Kevlar cord onto a rocket where the body tube itself is the engine mount? This one is going to be fairly difficult to see, but I'm going to show you. On this particular fin, you see it's a little bit rough down here, and it's a little bit rough along here. There's actually a piece of Kevlar cord that starts here, it goes around the bottom of the fin and comes up here, and it's actually glued down. So this is glued against the fin like this. And again, I did paint over that a while ago, but I want to show you what I did. So it does start this side, it wraps on the other side, and then it goes up here. You can see this line. This is where the Kevlar cord is, up here. Then it goes down inside the body. Going inside the body allows us to pack a fairly large Kevlar cord on the inside. So the whole issue of spotting this, recovery, is now solved by having a streamer inside of it. And we'll take a look at what that looks like. This was developed a long, long time ago, before I started using the eyelets. But again, space is a premium, so an eyelet may not always fit. In this case, it's just big enough that I did use an eyelet on this one. So you can see this is a 2-inch streamer module like this, size for this body tube. And it opens up. Here we find the streamer. As we've been talking about, it's got the toothpick for the mount on the front. It has the eyelet here for attaching everything. Everything's hooked together. So this is exactly the same as the standard build that I've been talking about, where we've got this recovery system based on the Kevlar blanket, Kevlar cords. And if you look at the size of this cord side, if we pull this out, notice this came out in a bunch, but it continues to unwind, and that's important to use that so-called over-under winding method. When I built this, I used a swivel, which is one of the larger swivels, and since then I switched to the smaller swivels. A small rocket like this does not need a large swivel, and I did put a larger amount of heat shrink on here. The idea was to say, okay, the heat shrink's going to hit the edge, and it's going to avoid zippering. But in general, I've never had zippering happen, so using CA glue around the edge is probably sufficient. You don't need as much of this heat shrink on here. And so you can see I have the swivel. I've got the heat shrink, putting that in place. I have a knot tying this together. Ordinarily, I slide a piece of heat shrink over that, but this is fairly small. And the Kevlar recovery system here, and our standard streamer module here. And the other improvement was this engine clip, which now holds in the engine with a positive mechanical mechanism rather than using friction fit. So now you can be pretty sure you're not going to lose your engine, or you're not going to lose your rocket. And again, a wrap of Kevlar cord around this point to hold it in place, with some E6000 glue on top of the Kevlar cord to hold it in place. Again, it dries as tough as an epoxy, very, very tough glue, and I really like it a lot. And it smooths out. It smooths out so easily that you can paint over it very, very easily. I'll just comment one thing on the E6000 glue, is that when you put it on, the glue is really kind of stiff and kind of gloppy. It's like a very, very thick pudding almost. It just kind of stays there. So the question is, how do you smooth something like that out? Answer is basically rubbing alcohol. This is rubbing alcohol. I simply bought at the grocery store. It's isopropyl alcohol, 91%, very high percentage. All you do is spray some on your finger, and then you just go ahead and rub it like this. And the E6000 glue rubs out just like you're rubbing down a wood glue. Smooths it right out, and it looks just beautiful. Once this is on launch pad, nobody even notices this. Unless you're looking for how I did this, you're not going to see all the changes that I made to it. So again, the Wizard rocket now is a very, very reliable rocket. I'm not going to lose the engine. When it's up high, I'm going to see it. When it's on the ground, I can easily find it. Very nice, reliable rocket. This is Model Rocket Engineering.